Okay, we're going to do problems 2, number 8. David is standing on top of the school's roof 5.3 meters off the ground.
So that's DV.
He's a high school nerd. He's in like
He throws his graphing calculator at 9.75 meters per second at a 55-degree angle. So we've got 55 degrees is here, and he's chunking it at 9.75 meters per second. And we want to know how far away it lands. So this thing is going to, of course, travel in a nice parabolic trajectory, and it's going to come down and break into a million pieces, and he laughs hysterically. No more physics! But he still has to take his test tomorrow, so then he's going to be sad. So here we cannot just use the range equation. We're looking for how far over did it go, so we're looking for dH. But we can't use the range equation because the range equation only works when time up and time down are the same. Is time up and time down the same here? No, clearly the time down is bigger than the time up. So the first thing we want to do is make a triangle. So we're going to have this, it's going to go at 55 degrees, this is 9.75 meters per second. And of course, it's going to break into both VVI and into VH. So to find the VVI, this is the opposite side, so we would use sine. So here we're going to take the sine of 55 times the 9.75. And we get 7.99. And over here we're going to use cosine 55 times 9.75. And we're going to get 5.59.
Make sure it's in degrees.
Yeah, if your calculator's not in degrees, you're going to be very sad. So that's the first step, is to break up the triangle, because we know our goal here is to find DH, and of course we know that DH is equal to VHT. Well, we just figured out the VH in the first step, so we know 5.59. We just don't know the time. So now we have to find time. Well, initially, am I going up or am I going down? Initially, I'm going up, so I'm going to find time up next. So step 2, I'm going to find time up. So of course my time up formula is VF minus the VVI over G, and VF is always going to go up if I'm going to go up to my highest point. So I'm going to have 0 minus the 7.99. Hey guys.
I mean, you guys are always like.
Sounds like a cocktail party in here.
No drinks.
No dress.
So we get 0.814 seconds to get to the highest point. So now that we know the time up, we want to find the time
Down.
but we have a problem. We can't find time down until we're falling from our highest point. We don't know how high we went. We know that he is 5.3 meters off the ground, but the calculator went higher than that. So next we got to figure out how high did the calculator go. So step 3 is going to be find the d up. So we find the dv equation, and there's 2 different dv equations we could use. You could use the one that we used a lot in part 1 and use this time, and then use this as your VVI. Or you can use the other d equation, and I like this one better because it uses all the same numbers we have here. So if we have the d up equation, that's going to be VF minus VVI, but these are both going to be squared. And so basically it looks very similar to the T up equation except we added 3 2's. So it's nice because I just use these same numbers in the same position, I just add some 2's to it.
Where'd you get the 7.99?
That is what we figured out here.
Oh, okay.
Was our VBI. So we want, again, since both of these equations are going straight up, we want only the component that's going straight up.
Gravity is negative, isn't it?
Negative.
Yes. And that way this minus and that will cancel out and give me
But
positive.
that minus would already have canceled out since it's the second part.
No, because this gets squared and this gets squared before they get subtracted.
Oh,
Squaring happens before subtracting happens. Mathematical hierarchy.
okay, so
Unless
So
it was
this number
incorrect,
gets squared and
then
this number
yes.
gets squared and then it's not parentheses out here and the squaring happens outside the parentheses. It's the parentheses are here, this square happens, this square happens, then they get subtracted.
Sign, amplifier. You see how that's the sign?
So we get 3.5. Now, is that how far I'm going to fall?
That's the highest point.
Okay, that's how high I got above the building, so now I need to take this height and do what?
time.
Add it to this one. So
Yeah.
step 4 is I need to add my D's together. So I'm going to have my 5.3 and I'm going to add 3.25 and that's going to give me 8.55. So I'm going to fall down. So now I know from my highest point all the way down to the ground how far I'm going to fall. So now I can find the
Time down.
time down. So now if I find the time down equation, that of course was 2 dV over g. And again, the whole reason we did step 4 and step 3 is so I could have the right dV to stick in here. So I'm taking this 8.55 number and sticking it there. So we're going to have 2 times 8.55 divided by 9.81.
It's negative from the 8.5.
It's falling down and gravity's falling down, so they have to cancel each other or we get error on the square root. So we get 1.32 seconds down, and we had 0.814 seconds up. So the total time it was flying sideways was, we have to add our time.
Oh yeah.
So t plus t plus down. So we're going to have our 1.32 plus our 0.814. So that, of course, was the whole thing that we were missing in the first step, which is really the last step. So the 7th step is just to find the dH equals VHT. So now we're going to have that 2.134 seconds times the 5.59 we figured out in the very first part. And we get 12.4.